Welcome to Chapter 2 in Geometry. Today we're going to begin the chapter talking about perpendicularity and what that means and how to apply it to algebra-based problems and also to proofs. So first, the definition. What is perpendicular? Perpendicular is defined as this. Lines, rays, or segments are perpendicular if they intersect at right angles, and in some cases it's going to be more convenient for us to say that they intersect at 90 degrees. Now, if we're talking about a geometric proof, right angles is generally going to be better for us. If we're talking about algebra-based problems, we're going to most often use the fact that they form 90-degree angles to solve those. You'll notice that right here we have, probably should use a highlighter, not a pen. This little symbol, this upside down T, represents perpendicular. So what that means is that if we have two segments that intersect, they'll make those right angles or 90 degrees. So let's start off with an algebra-based problem. It says here, given Fi is perpendicular, again, we've got that symbol right there, to Ri, the ratio of Fie to Rie is 3 to 2. So we have a ratio, and they tell us what this ratio is. That tells us that we're going to have to take that information and turn that into an algebraic expression. So if you see ratio, that means that the Fie, the first thing mentioned, is 3x. There we go. And Rie, the second thing mentioned, is 2x. Now, we just talked a minute ago about if we have perpendicular, there's really two main parts of it. Either they form right angles or they form 90-degree angles. They're essentially one and the same, but we want to make sure we use the part that's appropriate for us. Our problem says to find the measure of angle Fie, so I want an actual measurement. 90 degrees seems to be the better piece right here. What this means is that this angle right here, angle FIR, is 90 degrees. Now, using our angle addition, we know that if we have an entire angle and two smaller components of that angle, we can add those components up and get the large angle. So I'm going to write an algebraic expression, 3x plus 2x, and I'm going to set that equal to 90. Fie plus Rie added up give me my right angle, 90 degrees. So I'm going to solve for x. I get 5x equals 90. And I divide by 5 and I get 18. Problem's not over though, because I want to find the measure of angle Fie. So 18 is not my final answer. I've got to take that 18, which is the value of x, and plug it into my 3x. So I'm going to take my 3 and multiply it by 18. And I get 54 degrees. So that's the measurement of angle Fie. Now it doesn't ask me for it, but I could if I wanted to find the measure of angle Rie, take that 2 times 18, and that gives me 36. Now again, double checking, 54 plus 36 does give me 90 degrees. So it seems like we got the problem correct. Alright, let's get to a proof, show how that works with the right angles. So we have our statements and our reasons that we're going to set up. So once again, our given information is that we have perpendicular, two segments are perpendicular. So DA is perpendicular RW. So as soon as I get a diagram like that, I'm going to just start marking it up with the given information. And that gives me that these two angles are right angles. And I'm going to see if that really helps me. So I'm going to start off with the given information, and I'll say that DA is perpendicular to RW, and that's given. And from that given information, the fact that I have perpendicular segments tells me that I now have right angles. So I'm going to say that angle DAR and angle DAW, are right angles. And the reason I know that is because of the definition of perpendicular lines. So my statement is going to be this. Again, I started with perpendicular. That was my given information. Perpendicular forms, and then I'm going to say what it does. It forms these right angles. And again, the reasons are not the place to start introducing new words. So I'm good to go here. Perpendicular was already mentioned. Right angle was already mentioned. So now that I have right angles, from chapter 1 we already know that all right angles are congruent. So angle DAR is congruent to angle DAW. And we never mentioned anything about the measurement of the angle. We never said it was 90 degrees or anything like that in the proof, so we can't use congruent angles have the same measure. We're going to say that all right angles are congruent. That's exactly what we had to prove. Proof is over. We got it. Alright, in our last example, we have a rectangle given to us, rectangle copy. For what we're trying to do, we're trying to find two parts. First, the coordinates of point C. Notice they're missing our coordinates. And then part B, we want to find the area of the rectangle. So you have to know a little bit about rectangles in order to solve this problem. And the main thing that we're looking for is the fact that opposite sides of a rectangle are the same. So the distance from O to P is the same as the distance from C to Y. So if I look at my coordinates here, I know that from 6 comma 4 to 6 comma negative 2, there's no difference in the x direction. So the only difference is in the y direction. So I've got to figure out how far is it from 4 to negative 2, and I get 6. Similarly, PY and OC are going to be the same measurements. So if I can find out what PY is, then I can find out what OC measures. So PY, looking at my y coordinates, they're the same. The only difference is in the x coordinates. So I'm going from 6 to negative 8, and that's 14 away. So I know, because opposite sides of a rectangle are the same, that we have 6 here and 14 here. Now to find the coordinate, or the distance here from O to P, I just noticed that my x coordinates were the same, but my y coordinates were different. Similarly here, I know that to find the coordinates of C, my x coordinate is going to be the same as y. So I know my coordinate is going to be negative 8. And then because it's 6 up from negative 2, I take negative 2 plus 6, and I get 4. So my coordinate is negative 8, comma 4. You'll also notice that point C has the same y coordinate as O, and point C has the same x coordinate as y. Part B, we want to find the area of the rectangle. Hey, good news, I've already found exactly what I need. The formula is area equals length times width. Our length is 14, and our width is 6. So when I multiply 6 by 14, that's going to give me 84. Now you may be asking, what does that have to do with perpendicular? Why are we talking about rectangles? Well, we'll talk more about this in Chapter 5 and some special properties of rectangles, but these segments right here are all perpendicular. They form right angles, and that's the definition of a rectangle, is it has 4 right angles. Okay, we are done with the notes.